Somebody asked to explain how to do problems like this. So to explain that, we'll just go ahead and do number 63, and then you can apply what you learned from this explanation to completing numbers 64, 65, and 66, if they were assigned. Or, if not, for practice. Well, you might start by finding vertical asymptotes. We can't divide by 0, or our function will be undefined, and that's where the vertical asymptotes come from, usually. So, when is the denominator 0? When x equals negative 1/2. So we have ourselves a vertical asymptote at x equals negative 1/2, and you can see there's no vertical asymptotes in this function or this one, so that eliminates choices A and D, or whatever they were, yeah, A and D. All right. Next, how about horizontal or end behavior asymptotes? I would encourage you to call these end behavior asymptotes as opposed to horizontal asymptotes, because sometimes the end behavior, and by ends we mean as x approaches negative infinity and positive infinity, sometimes it's approaching a line that's not horizontal. It's still an asymptote, but it might not be horizontal. So let's just call them end behavior asymptotes. All right, to find the end behavior asymptote for this curve, we would say, what's the limit? As you move way to the right, what is the y value approaching? And if x is approaching infinity, the +2 becomes really insignificant compared to a value approaching infinity. And the +1 also becomes insignificant in this expression when x is approaching infinity. So, as x is approaching infinity, the y values are approaching x over 2x, or just 1/2. So as we go to the right forever, the y values are approaching 1/2, which is a horizontal line. It looks like this could be approaching 1/2 here, whereas this one, as we go to the right, the y values are definitely not approaching 1/2. They're approaching something bigger. I think we found our culprit. Right there it is. If we had gone on to find this limit, it would have been equal to a negative 1/2, which you can see is happening. And by the way, there's another thing to keep in mind, and that is zeros. When is the y value equal to 0? If the y value is 0, you are an x-intercept, right? So when is this y value equal to 0? When the numerator is equal to 0. And when is the numerator equal to 0? When x is negative 2, which existed in this graph, but not in this graph. So there's many reasons why we knew this is the correct answer for number 63. One more thing I would like to draw your attention to, which is the end behavior, which is as x approaches infinity or negative infinity, was it y equals 1/2, the horizontal line. In this graph, notice as x approaches infinity, the y graph appears to be approaching something like that. So the end behavior asymptote will not be a constant. It's going to be an mx plus b line. Anyway, well, you should try to figure that out on your own. Explore, practice, and see what happens. It's pretty interesting stuff. I hope this video helped.